You previously worked as an extreme scale team lead at the AI community Hugging Face. And prior to that, at the Gen AI platform Light On. We'll talk about, I have another question about Light On coming up soon. And there's a big question mark around scale these days, where the idea of bigger compute, bigger networks, bigger data driving more model capability. One of those things, more compute, okay, we can just have, you talked about hundreds of thousands of GPUs. You can have 1 million theoretically. It's an engineering problem. Same thing with bigger networks. We can have more model weights, or we can have more clever mixture of experts models. But bigger data can be tricky, because you already talked about earlier in this episode how, the pre-training can involve all the literature that's ever existed, all of the internet. So that could theoretically run into short supply. And so different people have different opinions. Ilya Sutskever said that if Gen AI's fossil fuel is human data on the open internet, we've exhausted our supply. However, other people like Sam Altman, Dario Amodei from Satya Nadella from OpenAI, Anthropic, and Microsoft respectively, they don't seem to think it's a problem, that scaling has no end in sight. Synthetic data seems to be part of the solution there. Do you think that, kind of engineering tricks you've mentioned in past interviews, how things like cleaning up data to remove duplicates had a big impact? So do you think that this kind of massaging the data that we have can continue to give us great results going forward, regardless of whether we have more of it?
I think, I think there's a bit of truth in every one of these statements, where definitely in terms of readily available data, we are starting to hit a limit where, there was a golden age where we were just starting to crawl the web and starting to improve your crawler, and then you add archive paper, and then there was kind of a golden age where data seemed unlimited. And obviously nowadays this is less the case. You can massage this data to improve its quality, to get better results out of what you get. You can order it differently, you can order it differently during pre-training, maybe put the lower quality data first so that you get more impact from the later high quality data. But ultimately, at some point, we have only, as humans, we have only produced so many words. So there might be a question, of this, of do we run out? I think, actually, I can't answer the question, have we run out now or when? I think it's actually quite complex. But I think I can answer the question of what's next, and what's already actually the case, which is we go back to post-training, where what's very interesting about post-training is that post-training enables model, and I'm going to use the word of Richard Sutton because he put it in a very elegant way. It enables model to learn from experience. So the models actually do something, as we discussed before, get the feedback on that doing, and receive that. And this is infinitely scalable, because this is essentially the experience of the model in the real world. Yes, currently we do this in simulators, we do this, we formulate these artificial problems, but it's already possible, for models to conduct an experiment in the real world and use that as a reward signal for reinforcement learning. And this, the bits of data we can get from this, there is no, there's no limit. It's practically, models can conduct as many trials and many experiments in the real world as resources allow. So I think this is a part, if you look from a more very large scaling perspective, this is where reinforcement learning is very exciting for this, is that actually it's a gateway to a much wider range of signals, a much wider ability to learn. And we are seeing this now. For a while, people were seeing reinforcement learning more as this only specialization layer, or only, post-training layer. But actually, it can be the trend, the bulk of the resources are going to be spent in the future on post-training, on reinforcement learning, because the models are going to learn from trying again and again across, billions of virtual environments. And eventually also in the real world against trying, their experiments, their own ideas. And this is obviously a very big frontier right now. And people are pushing really hard on it, and it's really, really exciting.